Hello, hello. Let's start today's session. Already on time. Welcome, friends. I am Karthik Jadhav. So currently, I am Prime Minister Research Fellow in the Department of Water Resources Development and Management, and I'm also a PMRF teaching assistant for this NPTL course, Irrigation and Drainage Engineering. So this course is designed by Professor Mailapalli, AGFE Department, IIT Kharagpur. So these are my contact information. So if you have any doubt related to this course, write down email ID, hypothetical subject, IDE. And you can also join this problem solving session on each Saturday for your related queries. These are the YouTube channel link where I'm uploading all the previous covered session. So I request you to watch you out by scanning this QR code, and also whatever lecture material I'm preparing, that also like I'm uploading on this Google Drive link. So go through it and let me know if you have any further required any further clarification on explanation. So currently we are at week number 6. So till now we have covered about basics of soil and water, its relation with the plant, as we are more interested towards irrigation part, and we know that irrigation is the largest water requirement sector. Agriculture is the largest water requirement sector, and it's very crucial to manage its water resources for sustainable agriculture water management. So for that, we have started learning about various terminologies related to the crop water requirement, irrigation scheduling, and then what kind of irrigation system we have, what kind of conveyance structure we have, and what what application methods that are like conventional method as well as certain modern irrigation methods like drip and sprinkler irrigation system. Um, we also talk about its design, operation, and maintenance part in last week. So currently we are at week number 6. So there we are basically talk about irrigation wells. So basically, it is about groundwater. Lecture timing, we know that. So before moving on, let's quickly recap like what we have covered. So in last week we have started with sprinkler irrigation system. So we have firstly defined what are the type of irrigation system we have based on spray pattern, based on major sprinkler system, set move system, or continuous system, right? So all they have further have a different classification based on its movement, and these are the description of each one. And then we have also discussed about components of particular irrigation system with the description and their essential fittings. So these are the overall layout of any micro irrigation system, whether it is a sprinkler or drip irrigation system. So they this kind of system have two kind of head, like one is a control head and one is a distribution network. So control head basically have all the pumping unit, certain uh, valves, then we have a filters to remove sediments, organic matters, and other small impurities. So that we have different kind of filtration. That also we have covered like sand filter, hydrocyclone filter, then we have media filters. Then we have distribution network. So once the water is filtered out, then we uh, carry that water at a field level for water requirement satisfaction. For that we have a different. So first we have a main line, and on main line we have sub-main laterals. On that laterals we have a drip emitters. So emitters basically is the final unit where water is coming out, and they have a specific discharge. So that's basically based on crop water requirement at particular crop stage. Then it is as this emitter plays a very crucial role at end. So we have also talked about performance evaluation of drip emitters using various manufacturing characteristics, operational characteristics, and hydraulic characteristics. Then in continuation with it, that we have talked about installation of drip irrigation system. So these are the certain field preparation. Then so this distribution of main, sub-main line, and this filtration system. And all this we need to design first on paper, and then based on the concentration of field we need to lay it out. So then once we install, the maintenance part is very crucial. So that basically maintenance of each components like filtration system, then sub main line, drip emitters, so that we have physical and chemical treatment. So that we have discussed already last time. Not going into details. So uh, sorry. Yes. So now, so these are the end of week number 5, where we have covered all the major irrigation system and its design and its maintenance parameter. Then now we are at week number 6. Week number 6, so basically we have started with the irrigation wells. So we know that groundwater is the largest freshwater reservoir that lies beneath the surface, and that we are using highestly at least in India for agricultural purpose, agriculture water management purpose. So for that reason, we need to understand its basic characteristics, what kind of aquifer where the water is stored, so we can better plan our like what kind of field we require, how to what extent we can extract the groundwater, and how it related like or uh, concerning related to groundwater quality. So, the unit which stores the water and timely release the water whenever it's required is called the aquifer. So basically, aquifer is a geological formation or part of formation or group of formation that yield a significant quantity of water is defined as aquifer. And aquifers example are sand and gravel. While aquefuge is a geological formation that contains no interconnected pores. It's like a solid granite and therefore can neither absorb or not transmit water. It is fused. There is a no transfer, no absorb of water. And we have aquiclude, so it is a clay kind of structure, so it is porous and contains water but not capable of transforming water in a significant quantities, okay, as much as aquifer does. Then we have aquitard. So aquitard is formation of hydraulic conductivity is too small to permit the development of well and spring, but significant sufficiently large to influence the hydraulic of aquifer adjacent. So its example is sandy clay. Just a second. Okay, so there are four type of major formation that we generally found beneath the earth surface. So that we have already covered. Okay, first one is aquifer, aquifuse, aquiflume, and aquitard. Then, if you see this picture, right? So this is in general to define what kind of aquifer we have. So there are generally three type of aquifer. So confined aquifer, sorry, unconfined aquifer, confined aquifer, and unconfined aquifer, okay, or leaky aquifer. Generally, confined aquifer is defined as if its bottom layer is having confining bed, it means it is not able to transfer much water and its upper surface is directly in contact with atmosphere pressure. That is known as an unconfined aquifer. While confined aquifer, so when aquifers is lies in between two confining bed, that is known as confined aquifer. And leaky confined or semi confined aquifer. So that in that case, either it is the upper bed or lower bed of the surface is leaky in nature. Okay, that is known as uh, leaky aquifer or semi-confined aquifer. Okay. Now, you all can also see that time required to reach rainfall water, natural rainfall or glacier water to reach at groundwater, right? Aquifer. It is too much high for confined aquifer. So, if you are extracting deep water, okay, suppose you have a tube well at your farm and you are tapping any confined aquifer that have a deeper layer, and now you are extracting water. So, you know that water extraction rate is too much higher, right? And you can see that recharge rate that is going to this kind of aquifer that is much lower. So, okay, so it takes centuries, right? Even centuries, even it is millennia age. Okay. Millions of years required to rainwater to reach a deeper layer. So it means very crucial to understand like what kind of aquifer we are tapping, what amount of water do we have in that, what kind of quality we have. Generally, in terms of aquifer type, generally in northern India we have unconfined type of aquifer, and we're tapping that because of annual formation. We have lower Himalayan region, and while as we go towards central India or southern India, we have a more confined type of aquifers. So there we found water. So these are about the types of aquifer. Now we have also covered about what different type of springs. So there are four type of springs. So spring, first one is a depression spring. So they are from formed where the ground surface intersect the water table, right? Where contact spring, so it's caused created by permeable water bearing formation overlying less permeable formation that intersect the groundwater, and artesian spring that release of water under pressure from confined aquifer either at the outcrop of a aquifer through opening in confined. Final one is tubular or fracture spring. So it is string from grounded channels such as lava tubes, solution channels, or these are the fundamental uh, of like unconfined aquifer, or you can say wetter zone, right, or unsaturated zone. So before this, you can see this unsaturated zone. So there are capillary fringe kind of formation. So that is due to surface tension. And this is the part of overall hydrologic cycle. Not going into detail, so this concept is very fundamental. So these are the different kind of swings that we have already discussed: depression, fall, contact, and pressure. And then we have started talking about aquifer properties. So there are various properties of aquifer that basically related to the transfer, storage, or uh, basically we require transfer and storage of water. So that property we need to define it, that we must uh, define to understand, okay, what is the capacity of an aquifer to store water or transfer from one place to another. What rate it can transfer. So we have started with porosity and void ratio that we have already covered in week number one. Then in this lecture, basically we have started with effective porosity. So effective porosity is basically portion of void space in a porous material through which fluid can flow. If you are aware about that, in total porosity also it is not like that all pores are contributed to water flow. Like that, right? Certain pores are not interconnected. Okay, so there are that's called dead end pores, so that are not taking part in the flow. So in that case, we are generally essential to define the effective porosity. Right. Then we have defined permeability. So permeability is the ability of medias to transit fluid, while hydraulic conductivity is the property of media as well as fluid to transfer water. Right. So rate at which water get transferred. So generally, have a higher sand or gravel have a higher hydraulic conductivity as compared to clay, as you can see in this figure. So for sand and gravel, it is up to 1000 meter per day, while in case of clay, it is 10 to the power minus 8 to 10 to the power minus 2 meter. So these are the unit of each one. So permeability have a unit of Darcy. So 1 Darcy is equal to 9.87 10 to the power minus 13 meter square. And hydraulic conductivity have a unit of meter per second or meter per day. Then validity of Darcy's law. So we have talked about Darcy's law. So Darcy's law generally fundamental equation in ground of movement, and it is valid only for laminar flow. So laminar flow is defined by Reynolds number. So Reynolds number we know that it is inertia force by viscous force, and generally it is valid if strictly valid when Reynolds number is less than 1. And in general, it is we can also accept it if it is less than. Then we define specific retention and specific gravity. So specific retention is the amount of water retained against gravity after being saturated, and it is defined as volume of water retained by volume of water. Then transmissivity. So transmissivity is basically rate at which water transmitted through its unit weight. Okay. So flow rate per its unit weight. Flow rate per its unit weight. Also known as coefficient of transmissivity or transmissibility. Defined by this kind of equation. So considering how aquifer is lies above each other. Okay. And then we have a specific yield. So specific yield is represent the water yield from water bearing material, and it's generally ratio of volume of water that will yield by gravity to its own volume. And specific yield is also called effective porosity. So effective porosity means like effective white space we have effective porosity. So it is basically tells about what amount of total pores that contributed to the flow. Okay, so that is called effective porosity is equivalent to specific. And also total porosity is equal to say that porosity is equal to specific yield plus specific retention. Specific yield is gained by gravity. So pores that contributed to uh, downward movement, and specific retention is water stay against gravity, right? And then apparent specific yield, so it is defined as the ratio of volume of water added or removed directly from saturated aquifer to resulting change in unit aquifer below the water table. That is known as apparent specific gravity. Then we define specific storage for confined aquifer and storage coefficient. So specific storage is volume of water that unit volume of aquifer release from storage under a unit decline in hydraulic head. And specific storage is defined by gamma and eta beta in bracket 1 plus alpha by and beta. So here gamma is unit weight of water, eta is porosity, B is compressibility of water, and alpha is vertical compressibility of solid or aquifer material. It is inversely proportional to the bulk modulus elasticity of aquifer. In general, it is defined as gamma and beta plus gamma alpha. Okay. So this component is related to the water, while this alpha, where alpha is given, that related to the. So specific storage is generally can say volume of water that unit volume of aquifer release. Okay, from unit decline in hydrology. While storage coefficient, it is volume of water release from storage of confined aquifer per unit surface area. Okay, and per unit decline in component of hydrology. Storage coefficient have a per unit area. So unit of storage coefficient is meter. Okay, and it is defined as SS, that is specific storage, into thickness of aquifer, and its values ranges from confined aquifer 10 to the power minus 5. well for unconfined aquifer, it's like this. Then we have talked about hydraulic resistance and leakage factor. So it is basically properties of or leaky aquifer. Hydraulic resistance basically related to the time. It's really basically of leakage factor. It's basically uh, provide resistance against vertical flow. Just a second. Hey, Prabhu. Let's continue. We are talking about the dark properties of semiconductor. Then we have talked about isotropy, homogeneity, and isotropy. So isotropy basically is the same equivalent, and its values are not changing in any direction. While homogeneous, there are equal, having the same effect. If you are taking any equivalent thickness, so like all like two equivalent thickness, then that anisotropy and hydrogen is then we have talked about confined and unconfined aquifer in detail and derived its related equations. Before that, we defined certain fundamental that are related to confined and unconfined aquifer. So, first one is the static water level. So, static water level is level at which water stands in well before pumping starts. Okay. Water table in creating well. Then pressure at static water level is at right. Then we have a piezometric surface. So height at which water will stand in a piezometer or pipe open to atmosphere and extend to confined aquifer. And rise of water in pipe is equal to pressure by weight of. Then we have pumping water level. So level of water in a well when pumps at any given rate and this variable and changes with pumping rate. Then we have drawdown. So that is difference in pumping and steady water level is known as drawdown. And area of influence. So whatever area which gets affected by pumping of well is called area of influence, and its and well yield. So well yield is basically volume of water discharged per unit time. That is specific capacity, so yield per unit product. And then open wells. Open well with diameter of 1.5 to 1.5 meter. Then we have then we have defined filter points, cavity well. So filter point is popular in the pipe region. Its pipe consists of screen fed shallow drain. Then cavity well. So we know that cavity well is famous for as it does not have a strainer and it having a confined aquifer. Strainer basically means screen and water penetrates only through bottom opening. Then we define partial penetrating well. So whenever if you are not tapping it like like it's shown it here. So aquifer thickness is B, but your tapping depth is only half of your thickness. So means it is partial penetrating. But whenever your aquifer, if you are tapping entire aquifer thickness, so basically partial penetrating well means well having a screen length less than the aquifer thickness. Then we define a derived equation for steady radial flow, confined aquifer and steady radial flow, unconfined aquifer. First we started with steady flow in a confined well. So for that we have first drawn we assume certain things that like we have validated our monitoring well at well into aquifer thickness and aquifer is homogeneous isotropic boundary is penetrated at thickness. So we'll having a steady state. It means whatever discharge we are doing from this pumping stage during pumping stage, it's equivalent to water coming towards the top and bottom aquifer bounded by bedrock of so since this is confined aquifer, it means its top and bottom layer have confinement. Well is pumped at constant rate and aquifer is seemingly infinite. Then we derived equation for this confined aquifer. So it is Q equal to 5 KBS pH by dr, and this estimation of T and K value of the confined aquifer. So we have already carried out. Then well loss that we have also discussed. I'm not going into detail. Well loss, aquifer loss, right? And similarly, we derived equation for unconfined aquifer. So that's other entities here. So it is like pi k h1 square minus h2 square divided ln r2 by ln. Now, before we move to question and answer session, let's take a 5 to 10 minute break here. Then we'll continue question and answer session. start our question and answer session. So let's start which of the following geological formation can both store and transport signal? So we know that any geological formation have a two characteristics. That is storage of water and transforming of water. To store water, we have certain characteristics like oil ratio, porosity, microporosity, while transformation, transferring water and properties like hydraulic conductivity,
Animal farm.
uh, know that aquifer, so that is the correct answer to this question. As it have both uh, storage and transport properties. While there is geological formation given here like aquifer, so it does not have any pore, so it cannot store and transport water. While when we have aquifluid, so it is porous but not it has a negligible transmission property. It is like a clay, right? So clay have a lower hydrolytic. Then we have aquitard. So aquitard have a very low hydraulic conductivity and only it slowly transport the water. And clay kind of structure and aquifer that is porous and permeable like sand. So it can both store and transport water. So correct answer is option C. Question number two. Soil zone immediately above the water table where capillary action can rise water is known as unsaturated zone. Unsaturated zone is all like it is also known as the Meadows zone, right? So it does not have any water content, and if it have water content, it's only due to either irrigation or rainfall or precipitation. Capillary fringe, so it is the correct answer. So capillary fringe is the soil zone immediately above the water table. Okay. So this is the capillary fringe. So this water level rise. Okay. This is rise in water level basically due to the circumstantial forces and friction and this is related to the evaporation. The correct answer is option B. Wider zone, so wider zone and unsettled zone are alternative name. Recharge zone, so recharge zone is zone from where recharge is going. The correct answer is option B. Question number three. Which type of spring forms when permeable water bearing layer overlies a less permeable layer intersecting the groundwater line. So see this is the spring is generated basically when permeable water bearing formation overlies the less permeable formation. So aquifer, if it is overlying less permeable layers are dropped, and in that case, whatever spring is occurring or we found that is known as contact spring. Okay, the correct answer is option B. So these are the so first one is the depression spring. So depression spring is when ground cuts the water table. Contact spring when water flow along the impermeable layer. artesian spring due to the confined aquifer under pressure when fractures flow. So ground to discharge through fracture. Well, so this question correct answer is option. Question number 4. In the diagram of aquifers, water stored in confined aquifer may take how long naturally recharge at surface. Generally, for unconfined aquifer, we know that water required shorter time. So it is in range from days to years, while in case of confined aquifer, so confined aquifer is a deeper aquifer. So if soil surface, then this the roots are there. Okay, then this the first layer water table, then we have here impervious layer. Okay, impervious layer. Again we have here aquifer formation, and then impervious layer. So this aquifer is known as unconfined aquifer. Okay, confined aquifer because only bottom layer is confining in nature and top layer is direct contact with atmospheric pressure. So whatever recharge will take place from surface first will appear confined aquifer, then it slowly move down toward confined aquifer. Confined aquifer, so this process is very slow because this confined aquifer is lies in between confining bed. So this confining bed is either aquifuse kind of structure or aquiclude. So this allow we know that allow water either it does not allow water to move or it allow at very slow rate. Recharge happening through this for this kind of aquifer takes much longer time as compared to unconfined aquifer, and that is in range from century to millennium. Correct answer is option. Question 5. Which formation is porous and stores but cannot yield significant due to low permeability? That is in case of aquiclude, right? Because we know that aquiclude is a porous store water but impermeable, does not transfer water. And aqueduct, so it is very low storage capacity and zero hydraulic underflow. In aquiclude, no pore space, there is no question about storage and transformation. An aquifer that store and transmit fluid. Correct answer is option. Question number 6. Artesian spring can occur only when artesian spring that occurs only when there is a confined aquifer is pressure plus pressurized water. It emerge eventually naturally without. So correct answer is artesian aquifer or artesian spring located. So confined aquifer is under pressure and water escape through turbine. Correct answer is option. Question number 7. Which of the following correctly lists the soil water zones in order of top surface to water filtration? So, first one, groundwater, soil moisture, meadows water, and deep line water. Now that last one is a deep line water. So this is correct. First one, ground place water, soil moisture is there, but soil moisture that starts with root zone. And meadow zone is generally start from below root zone to first appearance of water table. So first one is soil moisture, right? Soil moisture, then we have meadow zone, then we have groundwater, then we have deep lying groundwater. So correct answer is option B. entry of water is known as infiltration. So this infiltration causes soil moisture in soil root zone. So soil moisture, then we have a vadose zone, right? This entire vadose zone, then we have a groundwater, okay. And if it further goes down, then the deep lying groundwater. Question number 8. The static water level in a well is defined as the static water level is water level before pumping starts. Depth to which water flows after pumping starts. Vertical distance from ground surface to water level before pumping. It is option. So option B is question number 9. In confined aquifer, water level in a piezometer stands. So we know that confined aquifer lies in between two impermeable bed, right? Impermeable bed, bed having so whatever water is in between that is in the pressure. Okay. So due to the pressure, water table or piezometric water level stands generally above the this aquifer top aquifer thickness, and it's generally uh, similar to water table. Correct answer is option C. Above the confined aquifer top, depending on the pressure or how like question number 10. If static water level is 12 meter below ground, pumping water level is 18 meters. So drawdown is, we know that drawdown is equal to static water level minus pumping water level. Static water level is basically water level before pumping, and pumping water level is water level at the time of pumping or after pumping. Both, difference of both is known as drawdown. So both are given here 18 minus 12. So drawdown is 6. Correct answer is option A. Which of the following is a correct unit of well yield? So well yield is generally discharge per unit time. So discharge, we know that, or generally discharge, or you can say volume of water that aquifer drained. So volume divided by time. So volume have unit of meter cube, time have a unit of second, minute, day, whatever it is. Okay. So correct answer is meter per second or meter cube. Option B. Well discharge 60 liter per second and draw down. So specific capacity of well is, so we know that specific capacity is yield per unit. Right? So yield is volume by time, volume of water is drained this so many aquifer per unit time divided by drawdown. So yield per unit drawdown is specific capacity. So 65 so 12 liter per meter second is hydraulic resistance of semi-confined aquifer is expressed as, we know that hydraulic resistance C is equal to V square by AB, or you can say leakage factor B is equal to under root KB. C is equal to V square by correct answer is 14. Which of the following statement is true? So, tube well generally we know that lined pipe is there, so that is non-water bearing. perforated pipe or well screened. Generally one area in aquifer zone from where we are extracting the water. So having a diameter of 10 to 12 centimeter and no large like open. Correct answer is perforated pipe are installed in water bearing strata and have a diameter of 10 to 20 centimeter. So the incorrect option is open well. So correct answer is option C. Right. Because line pipe we are not using in right, we are using it that we are using in water. Question number 15. Repeat theme equation for steady radial flow well in a confined aquifer is equation for confined aquifer so by kb w ln r by r. Correct answer is option. Right. So we have already derived. So let's so next question: which of the following is not an assumption of steady state confinement? You know that steady state confinement have a certain assumption. So this assumption are steady state condition. It means hydraulic fluid value does not change with time. Constant hydraulic property. Homogeneous and isotropic. Aquifer is homogeneous and isotropic in nature. Then laminar flow must be there. So variation of masses flow. Aquifer is of infinite aerial extent. Water from infinite directions of aquifer and water is only flow horizontally. While this kind of limitation also have certain assumptions, so that already we have discussed, so we can go through this. Let's identify correct answer. Aquifer is homogeneous and isotropic. Flow is radial and steady. Well, correct answer is option C. Right? Whatever aquifer we are targeting, or whatever equation we have derived, well is fully penetrated. Correct answer is option C. Second, where the following statement are true. First statement is confined aquifer flow, pumping water level always fall below aquifer base. It is incorrect. Transmission is defined as T is equal to. First one is false, and second one is true. Because water level falls below pyramidic surface, that is not then match the following item. Radius of influence. So it's basically distance from well where pumping affects. It means radius of influence. You can see this radius of influence. So where if we are pumping water from this well and we know that it have a effect on surrounding aquifer, so water will come down in the surrounding area. But this radius of influence is distance where static water level is almost equal to its natural or relatively value at this distance. It means there is a no influence beyond this point. So it means it is basically help to design like how to use monitoring well, how to extract water, at what extent we can extract water. All this will help. In drawdown, so it is difference between static water level and transmissivity. So transmissivity is T is equal to K into B. A is hydraulic conductivity, B is thickness. So its ability to transmit water across the thickness. So correct answer is this. And we know that for confined and unconfined aquifer transmissivity have a different equation. So confining bed, so it is in general it is fully saturated, and whatever thickness of this layer is there, so that is equal to aquifer thickness. While in case of unconfined aquifer, so aquifer thickness is varying in nature. Okay. So due to that, value of our equation is also different in this case because you can see V1 and V2 is constant here, and V1 is different and V2 is also different depending on how far it is from. Question number 19. Thickness of the capillary zone above the water table primarily varies with. So thickness of capillary zone above the water table primarily varies with. We know that capillary rise depends on balance between surface tension forces and fine texture soil like clay and sand, so pores are small, higher capillary rise, bigger capillary. While pores texture soil, so it is larger pores and smaller capillary rise and thinner capillary. So let's see the question. So thickness of capillaries on above the water table primarily varies with the pores of size of soil. Porous space in soil. Answer is option. Question number 20. A cavity well is defined as a tube well which has no screen, right? No strainer, no only part blind well, but it does not have strainer or screen. Sorry. So this is the blind well, and it is not something does not have any strainer or any filter. different geological formation. The sum of specific layers retention is called. We know that it is equal to specific yield. It is generally provide the volume of water drained by gravity, while specific retention, that is volume of water retained against gravity after sum of these both are the fundamental aspects of it. Question number 22. The cubic Boltzmann assumption are used in analyzing counter flow in cubic Boltzmann assumption. We know that it is generally fundamental in unconfined aquifer. Okay, for a steady state condition. Correct answer is cubic Boltzmann assumption are flow is always horizontal and radial towards where and parallel to the hydraulic gradient is equivalent to slope of water. These are only valid for question number 23. Capillary water in soil is mainly held, so it is mainly due to surface tension. Right. Correct answer is option C. Now let's move towards numeric type of question. So first question. For that, let's take in mind defining around the area. Hmm? Slide down. Question number one. Confined aquifer has a thickness B is equal to 20 meter. Hydraulic conductivity K is equal to 25 meter. Radius of influence R is given as 500 meter and radius of well that is 0.2 meter. Original picture that we had is 40 meter. It represents say static water level and pumping water level is 30. Now we move to first of all, it is a confined aquifer. So for confined aquifer, we know that formula that will applicable is 2 pi kb h minus hw where r ln r by 2 pi k is given as 25 meter per day. Then b having a 20 meter of thickness. Then h minus hw is 40 minus 30 divided by ln r is equal to 500 divided by 0. Let's simplify this and find our final answer that will be 4017 meter cube per day, right? By balancing all these, correct answer is this. Now, next question, question number two. Two observation wells are located at R1 is equal to 30 meter and R2 is equal to 300 pumping well. So drawdowns are S1 and S2 that is given as 2.5 meter and 5 meter and discharge is given as 1800. In this case we need to estimate transmissivity. So similar to last equation, so it's also for confined. So it is 2 pi kbs, right? Numerical equation is this divided by ln r2 by r1 or ln radius of intelligence divided by radius of right. So kb is equal to t, so it is written here, and s is written as 1 minus s2. So now let's put all the givens here, okay, and identify T is equal to Q ln R2 by R1 divided 2 pi S1 minus S2. All these are given here. Let's put it in this equation, and final answer we'll get from this is 660 meters per day. Let's also try to solve by your own as during your mid exam or your exam or maybe during your PTL exam. That will Kelsey will be not allowed. So practice and try to identify answer. Question number three: Confined aquifer has K is equal to 10 meter per day, B is 15 meter, H minus HW is equal to 4. Basically, it is a drawdown. R is equal to 1000 meter. RW is zero point 0.1 meter and compute. We need to compute discharge per unit thickness. So that is Q dash. So Q dash is equal to we know that discharge divided by thickness of aquifer. So discharge is given by 2 pi kb s or 2 pi kb h minus iw divided rn by r by rw. So here we already have b. So b, this b will cancel it out and equation will only remain like this. Now let's put all the givens here and a final answer discharge per unit thickness is 27.3 meters square per second. Next and final question. So question number four. So unconfined aquifer is pumped at constant rate of 10 liter per second. So at steady state, observed door round and radial distance are 30 meter and 60 meter from well, are zero point 0.8 meter and zero point 0.7 meter respectively. The original pre-pumping saturated thickness of aquifer is 30 meter. Determine the transmissivity T of aquifer in meters per day. So we know that for unconfined aquifer, we need to use S test equal to S minus S square by 2H, right? Let's first write down given here. So Q is given as 10 liter per second. Let's convert it to meter cube per second. So it is 0.01 meter cube per second. And then multiply, should we multiply 86400 meter cube per day. So it is 864 meter cube per day. R1 is 30 meter, R2 is 60 meter, S1 is zero point 0.8, S2 is zero point 0.7, and H is 30 meter. Now let's identify S1 dash and S2 dash by provided equation. So S1 dash and S2 dash is given by this. And now we know that Dupit theme equation for confined aquifer is having this relation. So by making T as a questionable quantity, so we can write down formula as given here. And now let's put all the givens here and identified value of T. So T we have 9.82 divided by 2 meters per day. So correct answer for this question is this. So with this we have ended this lecture. So complete this lecture here. So in this lecture, we have basically discuss about irrigation wells. So uh, we have also quickly summarized week number 5, that is about sprinkler and drip irrigation system. And then we have discussed about irrigation wells, like what are the aquifer fundamental properties that governs the storage and transfer of water from one place to another place. And then finally we derived equation that provide discharge of confined and unconfined aquifer using their aquifer properties. That is fundamentally aquifer hydraulic conductivity and aquifer transmissibility. And then we have also solved certain multiple choice questions, right? And then finally we have ended this session with a numeric type of question. So I will request you to uh, more focus on this numerical type of question for your examination. If you have any query in solution of this, you can directly write down to my provided email ID. So with this, if you have any doubts, so we can take few questions before we ended up this session. So anyone, any question? So still we have 2 minutes left, so we can take queries. Uh, if you do not have any query, let's end up this session here. So, and I'm request you to watch out all the previous content in this provided YouTube channel, that I'm uploading all the content, and also all the lecture materials I'm uploading in this Google Drive folder lecture material. So you can directly just click here, and you will also receive this link to your email, okay, by NPTEL team. So thank you so much for joining today's session. And still I have certain fevers and cough issues, so I'm not able to come too much. Uh, not covered more detailed questions. So still, if you have any query, so I'm happy to answer all that query. This problem solving session or through provided email ID. Okay, so thank you.